A Containerized Journey Using .NET Core with Mike Sigsworth.
The Azure DevOps Podcast is a show for developers and DevOps professionals shipping software using Microsoft technologies. Each show brings you hard-hitting interviews with industry experts, innovating better methods, and sharing success stories. Listen on to learn how to increase quality, ship quickly, and operate well. And now your host, Jeffrey Palermo.
Welcome back to the show. I'm Jeffrey Palermo, your host, and make sure to check out www.azuredevops.show for past episodes and show notes. And I'm excited in the user group scene that I'm doing a lot of speaking to user groups lately. I've given out, and it's still open, given out an open invitation to speak virtually at any of the .NET user groups who are doing virtual meetings. It's been a lot of fun, and I've got two coming up in the next few weeks. One in Tulsa, TriNet. If you run a .NET user group, I'd love to get on your schedule. And if you're tuning into the podcast for the first time, the Azure DevOps Podcast is for developers who are shipping software with Microsoft technologies. However you're doing that, you're using Microsoft technologies and putting software out there. And so this show is for you. My goal is for all development teams to be able to move fast and deliver quality and run their systems with confidence. And if you have specific needs, well, then that's what we do as a company at ClearMeasure. We're a software architecture company that helps your team succeed and deliver world-class results. So today, I'm really excited to have as my guest Mike Sigsworth. And Mike is a principal software architect at ClearMeasure, and he's been developing for over 20 years, most of that in the .NET space. He is passionate about board games and is an avid listener of sci-fi audiobooks. Mike, welcome to the show. How are you, sir?
I'm good. Thanks for having me.
Well, to start, do you have any recommendations of sci-fi audiobooks that people should go check out?
I could go on forever about that. I actually last night just wrapped up the Hyperion Cantos. It's a 4-part series, and it is absolutely epic sci-fi. I would strongly recommend checking that one out.
Nice. Yeah, the change of books. I remember growing up reading so many paper books, and I do consume a lot of audiobooks now, but just in general reading. My kids are a mixed bag when it comes to reading. I'm working on that.
We're heavy into Dragon Masters right now. My son's 8 and absolutely loves that series.
Yeah, nice.
I do too, actually. It's very well written. Cool.
Well, today we're talking about a huge success story, and obviously there's no private information given out, but when it comes to getting success stories, it's a huge benefit for the listeners just to know how various technologies come together, what issues happen. And you're the architect for one of the teams at one of our clients that's made some big shifts, but a massive critical system. And you guys are y'all 100% .NET Core now?
We're about 95% of the way there. We still have a few itty bitty microservices to move over.
And this is just talk about the lessons learned moving from .NET Framework to .NET Core, figuring out when you needed to split something out to a separate Git repository instead of having it run as a part of maybe a central piece. What challenges did you have to overcome?
Well, I think were I able to rewind. Let's see, it's been almost 2 years that we've been going down this path. Were I able to rewind, I would do the .NET Core conversion separately from trying to containerize the application and getting it running in Kubernetes. We tried to do all three all at once, and there was a lot more work involved in getting it containerized and changing the build pipeline to work with containers. And then, of course, moving into Kubernetes, that's no simple task either. What we wound up facing throughout the last couple of years were some very long-lived branches that had the .NET Core converted code on it, but wasn't really ready to go into production yet. So we wound up having to do lots of merges or implementing features simultaneously on two different branches, which is obviously not ideal.
Mm-hmm.
So I think that was the biggest, mistake that we made during the whole migration. That said, it was good to have them all separated. We wanted to be able to ensure that it was running in a container in Kubernetes in the lower environments first and kind of have it running that way for a long period. And we wanted to, I suppose, not have to make multiple large impacts in production, whereas we could ensure that the whole thing was running in a container on .NET Core in Kubernetes and was scalable in our lower environments before making that big push out into production. So it made developers' lives a little bit harder maintaining a long branch, but in the long run, it worked out well.
And give us some general context, like what kind of system does this do? How busy is it? How many transactions? What is the shape of the environments? Things like that.
Well, it relies heavily on NServiceBus. I suppose I should point out that this is entirely a back-end system. There is no real front-end component to it. So it's a lot of message-based NServiceBus handlers. And
the banking system, essentially, right?
It's a financial system. So the client deals with online loans. And we're kind of the middleman between the front end, and there's different front ends and mobile apps and things like that. And then there's various back end, different vendors. There's a vendor that does the decisioning logic and deals with talking to the bureau and all that sort of stuff. So we are the glue in between all the different systems. We handle a lot of the analytics, data storage, and just keeping track of customer data and the applications and all of that information. And we feed a lot of that data into various different analytics systems like Adobe Analytics and Google Analytics. And recently we have an integration with Snowflake, which is an AWS sort of data lake analytics system. So yeah, we're kind of in the middle and the core of it all.
Mm-hmm. And just to get a little bit about scale, how big is this production environment, just to give the listeners an idea?
Well, we have 4 virtual environments that are still running some of the old legacy code, and those are extra large EC2 instances. And then the Kubernetes cluster right now has, I'd have to count, but we have hundreds of pods running and about 50 odd services running across all of that.
Okay. And we talked a little bit about on other shows about Kubernetes, but people are still ramping up. What is a pod and how do you guys have it broken down?
Well, a pod is basically just a container. It's an abstraction in Kubernetes terms. It's one of their objects that they use to manage scaling things up and down. So you'd build your app. Your app would live inside a Docker container, and your Docker container would live inside the pod. And it's technically possible to have multiple containers running inside a pod, although I haven't come across a use case why that would be necessary. Yeah, pod is just, think of it as a container.
Okay. So 50 of those roughly, and then four of the extra large VMs. And you guys are spread out all over the place. As far as technology, it's all .NET, but your environment's in AWS, right? Yeah.
So counter to the name of the podcast, this is all run in AWS, and we actually don't have anything running in Azure at all. So
yeah. Well, hey, this show is for people shipping software with Microsoft technologies, which you can't do anything with Microsoft without using the whole ecosystem. And AWS does a pretty good job supporting Microsoft technologies as well. So you tackled containerization, the move to .NET Core, splitting up a bunch of stuff into smaller services, all at the same time. So if you were to sequence that, what is there a right sequence?
So just a small correction. We didn't split things up at the same time. These things were all like the way the project has evolved. It's about a 5-year-old project. It's more of a product than a project, actually. But over those 5 years, at the beginning, it started off as this big monolithic service. And this was all before I joined the project. It was divided up into multiple different microservices. So we did wind up with, several dozen microservices before I had joined the project. So that part was already done. Moving them to .NET Core, by far the easiest step. Actually, moving to .NET Core is, once you've done it once or twice, it's super easy to do it everywhere else. Some of the struggles that we had moving to .NET Core were just because certain open source packages aren't available yet in .NET Core, or the maintainers don't actually develop that NuGet package anymore that you need, so you have to find a replacement. And those are the biggest risks. Moving to .NET Core is, I don't feel that there is a whole lot of risk involved in it, because you can leave your logic mostly the same. So if your business logic doesn't change, then your tests actually still pass and they don't need modification. So the risk of adding regressions into the code is mitigated. But as soon as you find, we need to completely change this one library that we use for data access, which is one of the things that we wound up discovering. We were relying on a Dapper extensions project that is not available in .NET Core. So we had to completely move over to a new one. So that was a big risk, but we actually decided to implement that first in the old code and release that to make sure that it wasn't going to cause any regressions. And then we were able to more safely merge that change into the .NET Core upgrade, so that we at least had it isolated if it was going to cause any issues. Unfortunately, there were minor issues with that, but nothing that wasn't easily hotfixed. Losing my thread here. So
I think you touched on something that's probably widespread just with .NET Core. It's, this library is not available. Now what do I do? I made the assumption but there's so many libraries, and Dapper, I think, is one of those, was probably going to save a bunch of people, especially when it comes to reading from all kinds of various data sources. I mean, the list is a mile long, data sources the .NET Framework can go against, and then .NET Core is much shorter. For instance, just Microsoft Access, for some example. Tons of old .NET Framework, applications go against the Jet database and the ACE driver and the OLADB. And .NET Core, 3.1, finally brought over just the baseline OLADB APIs, which is not what you need, but then it allows, if you have that, what is essentially a COM-based driver on the Windows computer that it's running on, it does the binding, and then you can use Dapper to go against an arbitrary OLADB source, and then it works. So it's I think might end up being a pretty universal bridge for a lot of people with some of those. You can even, people who are writing SQL statements against Excel workbooks. I mean, there's just so many things that have been done over time.
I don't want to give the false impression to any listeners that Dapper doesn't work on .NET Core. Dapper definitely works on .NET Core. It was a third-party Dapper extensions library that did not work on .NET Core, and that basically allowed you to have like insert, delete kind of extension methods, whereas Dapper usually expects you to provide raw SQL. So that was the one thing that was missing. And the Dapper.contrib NuGet package is the one that you should be using for .NET Core if you do face that challenge.
That's a good tip. All right. So what was continuing your thread?
Right. So moving to .NET Core, as I said, was the easiest part. Getting things running in containers. Once you're in a container, it's nice. You can have it running in Linux with .NET Core, and then of course you can host it in Kubernetes. Containerizing, again, it's pretty easy to get things running in a container. You just have to have the right Docker file, and for the most part in Visual Studio, you can right-click and containerize, and it's done. What's hard about containers is the hosting of the container. running an app in a container locally using Docker Run or even Docker Compose, piece of cake. It's when you need to get it running in production and you need to scale it up and you need to make sure that it still has connectivity with databases and, talking from one pod to the next. There's a whole lot of pieces that you need to get right in order for that to work. And that's where, I guess, the complexity of Kubernetes really just hit us like a freight train, so to speak.
Mm-hmm.
Kubernetes it's no joke. There is a lot to learn there. It's nice now that we have it working. And actually, I had a really fun experience with Kubernetes and NServiceBus the other day. We discovered a bug in one of our NServiceBus sagas. And for those that aren't aware, a saga is basically just like this really long running sort of state machine of business logic. And it's all persisted in the database. And we had discovered about a month ago that we had a bug in one of our sagas, and it wound up, we had about 600,000 sagas that were stuck in the database and they weren't able to complete, because when a saga completes, the database entry is essentially deleted.
Mm-hmm.
So we had 600,000 of these things sitting there, and we did the analysis, figured out how to fix the bug, but then we had 600,000 sagas that we needed to churn through. And with Kubernetes, we were able to just scale up the pods so that they could consume the messages from the queue, because the sagas are all in a message queue. So we just scaled up pods, and they just kind of went through and as quickly as they possibly could, just read the messages from the queue and tore through them. At one point, we were processing about 350 messages per second across that one endpoint, NServiceBus endpoint. It was fun. I spent a few hours looking in the Service Pulse tool. Anyone who's familiar with NServiceBus, if you're not using Service Pulse, it's a fantastic tool, and we were able to go in and see how the critical time and the queue length and all these different things were reflected through a few graphs, and then just kind of scaling things up and watching that throughput increase and just keep increasing as we added pods to it. So.
Well, comment on NServiceBus as well, because that's the technology's been around a long time. It's very popular and does a great job. But with this shift, multiple shifts with microservices and queuing and containers and cloud and .NET Core, has NServiceBus fully shifted, and as people are adopting some of these, they're thinking, oh, should I use that? Or is that one of the many libraries and tools that's going to be kind of left behind and stuck in the past? What's your opinion on that?
Oh, absolutely not. NServiceBus it's core to our whole infrastructure. And they do support .NET Core as well, and have for at least a year on version 7, I think. I shouldn't quote versions. I'm not sure. I think maybe even version 6, they had some .NET Core support. But no, they definitely have their eye on the horizon for .NET Core, and have they support .NET Core 3.1 right now. And actually one thing that they've recently added would have been nice to have about a year ago when we were doing this whole .NET Core conversion. I think the biggest change when you're going to .NET Core is a lot of your application bootstrapping code is going to change. There's no more global ASACs. There's, your program.cs is gonna change. If you're using Windows services, and the way that your whole bootstrapping has to change. And NServiceBus a year ago was not really up to date to make that easy to get an endpoint spun up. There was this sort of complicated dance you needed to do to get NServiceBus to be aware of your IOC container, but then also you needed your IOC container to be aware of the NServiceBus endpoint. And there was this kind of circular relationship that was tricky to manage. So we built a lot of our own infrastructure, or I guess configuration code, to help us bootstrap NServiceBus and everything else in our services. And about 3 months ago, maybe 4 months ago, they released a very similar looking way of doing it, and that's built into NServiceBus now. So they certainly have been keeping an eye on the new best practices of how to do .NET Core startup and configuration and things like that. And it's very intuitive now and looks a lot like every other library in .NET Core.
The Azure DevOps Podcast is sponsored by ClearMeasure, a software engineering firm and Microsoft Gold partner, empowering development teams to be their best. ClearMeasure equips developers with the DevOps tools, methods, and automation necessary to focus on building their applications, rather than wrestling with builds, deployments, or environments. Click clear-measure.com to see whether a DevOps implementation is for you.
Now, you've fully containerized your environment, and as I understand it, you guys have pretty much a zero downtime deployment process. Is that right? In most cases?
In most cases. I mean, once something is running in Kubernetes, you can use a rolling deployment, and there is zero downtime with that. It's actually really interesting you bring that up, because there were a lot of caveats that we discovered with the rolling deployments. Well, it was a few things. It was rolling deployments and pod auto-scaling in Kubernetes. Really what it boiled down to is anytime a pod shuts down, and that would happen if you were scaling a pod down, or if you were doing a rolling deployment and has to turn the old pods off and turn the new pods on and such. Anytime the pod shuts down, what happens to your API is it essentially gets closed for business, right? It stops taking requests, and any requests that are ongoing, if they take longer than a certain duration, then those threads get canceled, and then the requests get canceled. So any requests that are coming into your API can, get lost, so to speak, or the client would see a 500 exception coming back because the thread was canceled. So there was a lot of issues that we found in there, and several weeks of experimentation to get it fixed. Probably worth a blog post, honestly, on its own. But essentially, there were a few tricks going on in not only Kubernetes, but also in ASP.NET Web API. You need to tell the Web API that the shutdown delay, you can configure the shutdown delay to take like up to 30 seconds. And that causes it was so long ago that we did this. I'm trying to remember the details. That causes the API to stop accepting requests, but then it'll wait 30 seconds before it actually terminates. And that gives Kubernetes long enough to remove the pod from its load balancer. So Kubernetes has pods, and it also has a concept of a service, and the service is the load balancer. So a request would come into the service, Kubernetes would look at all the pods that it's aware of for that service, and it would pick one to route the request to. But if that pod is in the process of shutting down, sometimes it's not removed from the load balancer quick enough. So a request could still get routed to your API, even though the ASP.NET API is shutting down, and it shouldn't accept any requests. So having that shutdown timeout increased to 30 kind of just was a buffer time to allow Kubernetes long enough to remove the pod from the load balancer, even though it should have already been aware that it shouldn't be routing requests to it. So I don't even know if that's a bug in Kubernetes, but it was a tough one to figure out. But it is working now. Mm-hmm. So the rolling deployments are working with the APIs better now that we have figured that out. And just to give NServiceBus more props, we never had any issues like that with the NServiceBus handlers, which don't run behind APIs because they are purely atomic, essentially. They read a message from a database queue, and if there's ever an error or you kill the application, the transaction just rolls back. The message goes back into the queue, and everything is as it was before it started. So that's a humongous benefit from NServiceBus, is the transactionality and the atomicity of the message handling.
Yeah. Well, with this type of system architecture and so many different concepts at play, how did you piece together your DevOps pipeline?
It was again some more trial and error and trying to figure out what the best tools would be. We were using TeamCity and Octopus Deploy before, and we wanted to keep Octopus Deploy, and TeamCity just didn't really fit in anymore. So we stopped using TeamCity. We discovered that Octopus Deploy allows you to include it's kind of like a NuGet package feed for containers, and it's called Helm. Helm rather is the tool that creates the package, which they call a chart. And you would put all of your charts into a repository. So we use a tool called Chart Repository, which provides us a repository feed that we could configure in Octopus, and our Octopus release is triggered by a new package getting put into that feed, basically. And when we discovered that functionality in there, it kind of triggered us to look more into Helm as a packaging utility for our containers, and it's worked pretty well. But we still needed that sort of TeamCity component to run our tests and create our Docker containers. We publish the Docker containers to Docker Hub, and then you need to create the Helm chart around the Docker container. We have integration tests that run in Docker, and you still need that CI component that's going to be able to run all those little bits and pieces for you. And for that, we chose AWS Code Build. And AWS Code Build is a finicky tool. I've always got my eye on GitHub Actions, hoping that it's going to get there, that we'll be able to maybe move all this stuff into GitHub Actions and out of Code Build. I don't think anyone on the team is a humongous fan of AWS Code Build. The challenge with this whole CI/CD process, though, as you can tell, we have so many different tools that we needed to make work together. Helm and Docker and Octopus Deploy, Code Build, and everything else. And finally getting it all deployed into Kubernetes. Then you have configuration management and secrets and all these other things. So it was, it took almost as long to get our CI/CD process working well as it did to convert all of the microservices over to .NET Core and get them running in Kubernetes.
I bet. Yeah. Well, talk about your testing surface area. How do you know that something's not destabilized whenever a new Git commit comes through?
We have a few different layers of testing. There's the unit tests. Obviously, we have integration tests that run against the database. The integration tests on the legacy services, before we containerized everything, they would just create a new temporary database on the centralized database server. But with Docker, you can actually run SQL Server in a Docker container. So when we run our integration tests during the CI process, it will spin up a SQL container. It will bootstrap the container we use Roundhouse to run all of our migration scripts. So we'll bootstrap SQL, run all of our migrations so that the database looks as it's supposed to, and we can run any scripts that we need to put test data in there. And we just run the integration tests with our connection strings pointing at the Docker container for SQL. Beyond that, we also have a set of smoke tests, and these are actually built by the client. We didn't write these, but they are basically web tests that go and orchestrate the front end, doing automated clicks and things like that, as well as some that do direct API calls, and that's like the full systems integration level testing. And if those aren't passing, then that's usually a cause to go and figure out that we've got some logic bug that wasn't discovered through an integration test. When you have 50 microservices, they all depend on one another, and a change to one microservice can cause issues with another service. So having that full suite of system level testing is essential, because you're not going to find all your bugs if you just integration test a single service. I think there's a lot that we could do to improve there. And that's just probably our biggest source of technical debt, I think, right now is not relying so much on the client's suite of smoke tests, but having something that would go and exercise just our APIs, perhaps. One of the things I read about, it's been many years ago, but contract-driven development, where you would essentially publish contracts from your APIs, and then you be able to drive your testing of other services to ensure that they are fulfilling the contracts of other services. I would need to do more research into that, but that's about it. 3 layers of testing.
Okay.
And we would like to add that extra layer of automated API testing, integrated API testing, maybe with Postman, something along those lines.
And for such a massively busy system, what's the necessary structure of the team?
Well, our team at ClearMeasure is relatively small. There's 5 of us now, 4 or 5 of us now. The team fluctuates, and we have a lot more that we do for the client than just this sort of core service layer thing. There's a whole nother initiative that's been going on that's taken 2 people off of the core team. So right now there is basically 1 DevOps guy, and I contribute on DevOps about 50-50 as well. And then we have another full-time developer, and she has been the mastermind behind all of the .NET Core conversions, as well as the reluctant tester going through. She's been incredibly thorough going through and ensuring that all these .NET Core conversions have been tested 100%. So pretty small team. And then I'm kind of there in between managing and doing as much as I can on every side and understanding how it all knits together.
So Mike, besides the good sci-fi books, for people who are kind of intrigued by the journey that you described and some of the technologies, are there any go-to resources that you found indispensable that maybe the listeners would want to check in on?
I mean, you just got to read the documentation. Kubernetes documentation is thorough, very thorough. It's written almost at an academic level, so it's difficult to digest, and it's evolved over the last year. But yeah, you really just got to go to the source. A lot of the stuff that we're doing is so new that you encounter a problem and you just got to Google it, and chances are you will not find an answer on Stack Overflow. You've got to find some obscure blog post of someone that's actually doing the same thing as you. So yeah, I don't think that there's a go-to resource other than documentation and Google, really.
Now, in the few years down the road, when all the cloud providers have just these plug-and-play container or Kubernetes services where you're just like, oh, we'll run your container. How many instances would you like? Will you miss the bleeding edge that you've been on, or will you happily give up some control in order just to say, run my stuff?
I would happily give up some control so that I don't have to manage a Kubernetes cluster on top of it. Yeah, it's a full-time job understanding and running and configuring Kubernetes. So if there's a platform that offers that, jump on it. If you don't need that infinite scalability, maybe don't even consider Kubernetes. I think you could probably get away with just running a single container in like an Azure app service. You can point it at a container and you just have a single instance. If you don't need that scalability that Kubernetes provides you, then it's definitely overkill for most people.
Yeah, that world is changing fast these days.
Yeah,
so next year we'll see what it is. But well, thanks, Mike. Thanks for coming on the show and sharing us what you've learned. These are hard fought lessons, and I know the listeners appreciate it. So thank you.
Thank you. Thanks for having me.
All right, and until next time, keep shipping.
You've been listening to the Azure DevOps Podcast, a show for developers and DevOps professionals shipping software using Microsoft technologies. Go to www.azuredevops.show for show notes and other episodes. On behalf of your host, Jeffrey Palermo, and our sponsors, Thanks for listening, and may God bless you.